Hello everyone and welcome back to our videos. Today we will talk about the sound. What is the sound? The sound is a wave that is its vibration that travel through a medium like air or water. If you drop a rock into a bucket of water, you disturb the surface of water and create ripples. The ripples or waves which travel away from the impact. The ripples cause the height of the water to change, going up and down as the wave moves away from the splash. These waves are visible with your eyes and have a number of properties. They have a maximum point called crest and a minimum point called trough. They have a wavelength which is the distance from the particular crest to the next one. They have an amplitude which is the distance from the center line to the top of the crest or to the bottom of the trough. They have a frequency which is the number of waves that passes a fixed point per second. Also, they have speed which is just a wavelength times frequency, and they have a direction. In the study of physics as it applies to practical aviation maintenance, we are interested in sound, not so much for what we hear, but as a study of the way it travels either through the air or through a solid medium. Sound intensity. The sound intensity is determined by the amplitude of the sound wave. As we talked previous, the higher the amplitude, the louder the sound. So we can say that the sound intensity, it means the loudness of the sound. Sound intensity is measured in decibels. A decibel is the ratio of one sound to another. 1 decibel is the smallest change in sound intensity, the human. Approximately 60 decibel is a comfortable level for conversation and background music. On the other hand, loud music peaks at more than 100 decibel. Sound that reaches approximately 130 decibel can cause pain. Before we talk about the frequency, we will talk about the wave. Wave is a vibration which carry energy in it. This our wave, and we can imagine here we have a line here to make a positive and negative waves. So here when we have a set of positive and negative, we will complete a 360 degree of the electrical. So this is called cycle. So when one set of positive and negative values completes by an alternating quantity, or it goes through 360 degree electrical, it's said to have one complete cycle. So this our one complete cycle, and when we see here we have two cycles. This the first cycle, and here we have the second cycles. After we understand the meaning of wave and the cycle, now we will talk about the frequency. What is the frequency? The frequency is the number of cycles made per second by an alternating quantity. If we back to the first definition, we find here we have a cycles, and we talked about the cycles in the definition of waves. How many cycles we have here in this wave? We find that we have two waves. This is the first wave and this is the second wave. How that's come? I will tell you. Here we have a 30-second degree. So when the wave have a 30-second degree, one is the positive and the second is the negative. This will complete one cycle, and here we will say we have the another cycle and it finished in the 360 degree. So when we back to the definition, we find that is the number of cycles made per second. We have how many cycles here? We have two cycles. How many time? By 1 second. So we got it, the meaning of frequency. What's the unit of frequency? It's measured in a cycle per second, or hertz, and is denoted by F. So when we see here, we find that the frequency equal to 2 hertz. Why we say 2? Because we have two cycles in 1 second. So as we talked about, the frequency is the number of vibration or cycles completed per second. It expressed in cycles per second or hertz as we talked. Frequency of sound determines its pitch. The higher the frequency, the higher the pitch. Sound propagation. There are three things necessary for transmission and reception of sound, and they are: the first one, the source; the second one, the medium of carrying the sound; and the last one, we have the detector. Sound is any vibration of an elastic medium in the frequency range that affects our auditory senses. This range varies among different types of animals and even among different humans. However, sound waves differ from water waves in that they are made of series of compressions and expansions or rarefactions. When the tine of the tuning fork vibrates, it moves back and forth away from the fork. With each movement in one direction, the surrounding air compresses and expands, setting up a series of pressure changes. These pressure changes, while extremely slight, are enough to vibrate the eardrum. Doppler effect. When a source of sound moves, the frequency ahead of the source is higher than the frequency behind it. This change in frequency is called the Doppler effect, and it accounts for the difference in sound as an airplane passes over you. As an airplane approaches, the sound becomes both louder and more highly pitched. When a body that is producing sound moves through the air, the sound waves progress out ahead of the body at a higher frequency. Moves through the air, it creates vibrations or sound waves which move outward. If an airplane flies slower than speed of sound, the sound waves move out ahead of the airplane. However, if an airplane flies at speed of sound, the sound waves cannot travel ahead of the aircraft. In this situation, the sound waves build up immediately ahead of the airplane, forming a shock wave. In any uniform medium, under given physical conditions, sound travels at a definite speed. However, in some substances, the velocity of the sound is higher. The speed of sound varies directly with the temperature of the air. For example, at sea level in standard atmospheric conditions, the sound travels at 661.7 knots, or about 340.4 meters per second. Mach number. The term Mach number is used to represent the ratio of speed of the airplane to the speed of the sound in the same atmospheric condition. So, when the airplane travels at exactly the speed of sound, it's said to be traveling at Mach 1. 2 times the speed of sound is Mach 2. If the airplane traveling at 3/4 the speed of sound, it's traveling. The last thing we will talk about today is the resonance. The natural frequency of a given object is the frequency where that object vibrates naturally, or without an external force. If two objects have the same natural frequency and are set next to each other, when one of them vibrates, it can transfer its wave energy to the other object, making it vibrate. This transfer of energy is known as resonance. Because resonance induces vibration, it can exert destructive forces on an aircraft. For example, it's possible to have portions of an aircraft, such as the propeller, vibrate in resonance at certain engine speed. If the vibrations are strong enough, they can create stresses in the aircraft that could lead to structural failure.